Hi there, and welcome back to the Ingrain Workshop. I'm Rick, and today we're going to be upgrading the service entrance to the workshop. But before we do that, I need to share this quick disclaimer. This video is for entertainment purposes only. This is not an instructional or a how-to or an educational video. Do not attempt to do anything you see in this video because it could result in your death. With that out of the way, let's get started. So before we start the project, I wanted to just give you a little bit of history on what's actually currently installed in the workshop. About 10 years ago, I installed 6-2 underground. 6 is the gauge wire, 2 means that there's 2 hot legs, and then the 1 bare copper ground. Instead of doing it through my house panel in haste, I went ahead and just took the meter cover off the meter socket, pulled the meter, and then tapped into the bottom lugs of the meter and ran the conductors out to the workshop. And then at the panel, I installed a 50 amp breaker. So there was no way for me to really cut the power off completely to the workshop. So because I needed to upgrade anyway, I'm putting in future projects going to be a Mr. Cool unit. I was going to need to increase the amperage anyway. 50 amps was just not going to be enough to handle the load of the workshop, plus the addition of a Mr. Cool unit. So I decided to install 4-3 in the ground, which is a black and red hot wire, white neutral, and then a bare copper. I think the copper might be a number 8 or number 6, and then the actual gauge wire of the hots and the neutral are 4 gauge. So, but instead of double tapping into my meter, I'm going to remove that double tap completely, and then take the new conductors, run them up into my attic of my house, and then drop them into my house panel, and then install a 100 amp sub-panel breaker in my house panel. This way I can cut the power off to the workshop anytime I need to work on anything out here. And it's just the way it should have been done to begin with. Alright, so with that said, let's get started.
Okay, so the first thing I had to do was basically just break out the shovel and start trenching by hand. Keep in mind that this is a live wire that I'm trying to trench out. Now granted, it is inside conduit, PVC conduit, but it was something that I couldn't just go rent a trencher and trench it out. I just didn't want to take that risk, so I just hand dug the entire trench from the side of my house here all the way over to my workshop, which was about 100 feet. Also buried in the same trench when I installed the original service entrance was a coaxial cable and I think a 6 or 12 twisted pair telephone cord. I thought 10 years ago that I might have cable and a telephone in the workshop. I never got around to doing that. So this time when I go back with a new service entrance, I'm going to install Cat 5, and this I definitely will use because this will give me the ability to have Ethernet and Wi-Fi inside the workshop. But this is a slow process, and it took me about 2 days, a whole weekend, to dig this out by hand, so I'm not going to bore you guys with it.
Okay, so the first thing I'm going to do is take and start uncoiling the 150 foot of new service entrance that I'm going to install from my house panel out to the workshop panel. Now the conductor size is a 4-3 in a ground, which means that the wire size is 4 gauge. 3 wire means that there's a black hot, a red hot, and a white neutral, and then a ground. I think it's either a number 6 or number 8 ground. So the first thing I'm going to do is uncoil all the wire and make sure that I've got 150 feet of service entrance conductors to install between the house panel and the main the workshop panel. Okay, I'm not going to break out a tape measure with my tape measure and measure it. I can pretty much tell that I've got 150 feet. So the next thing I'm going to do, since not only are we putting in a new service entrance from the house to the workshop, I'm also going to install Wi-Fi. So I'm going to have to run Cat5 wire with the electrical, so I'm going to unwind that now to make sure that I have the same length of Wi-Fi as I do conductor. Okay, now I'm going to take and return this back to Home Depot, tell them I got the wrong Cat5. Just joking. Okay, so now that I have the conductor and the Cat5 cabling all laid out, now I'm going to take and go get 10 sticks of 1¼ inch conduit and start putting everything in the conduit.
Once I got the conductors inside all the conduit, then I went back and then just started gluing up the joints. You'll see here I did have just 190 in my run, or I should say one new 90. I'm using the existing 90 that's at the workshop, and I left that in the trench, and I'm just going to install a reducer. I think it's a 2-inch 90 to install this 1¼ inch pipe, and then it's just, you know, rinse and repeat all the way down the line. I think I had 10 of these joints to glue up, and I'm not going to show you all 10, but basically it's the same thing. Just slap some Cantex glue on it and glue them up, and let them set up for about 5-10 minutes, and you're good to go. Okay, here I've got to take and drill, I think, an 1¼ inch diameter hole through my truss so I can get my conductors up into my attic space. I'm using a Forstner bit here. You can see that my left hand is on an 1¼ inch conduit, and that was an 1¼ inch conduit that I had installed when we ran electrical out to our little tiny house in our backyard. So I'm basically doing the same thing for the service entrance to the workshop. I'm just going to take and drill a 1¼ inch hole here so I can run the conductor up into our attic space. And the metal conduit to the right is the service entrance from the power company. You can probably see the weatherhead just above the roof line there, and that's where the main power feeds, and then it feeds down the exterior wall to my meter socket. Okay, so I took and got a 1¼ inch Forstner bit and drilled a hole through my truss. I did the same thing a year ago when I installed a sub panel in my tiny house, and you can see right here is where I drilled the hole. So I basically did the same thing here, and this is going to be for the new service entrance for the workshop panel. Okay, so now I have the conduit, the 1¼ inch conduit installed up the wall, and then the 1¼ inch hole that I drilled with my Forstner bit, I used that to push the excess conductors through that hole and into the attic. So I left about 10 feet of excess conductors, so I'll have enough to go from there to the house panel, which is right here at the back door. And also the Cat5 cable is run through that same hole. So the next thing I need to do is take some 1¼ inch pipe straps and install 3 pipe straps down the wall here and make sure that I plumb up the conduit. And then I'm going to dig out the trench a little bit more and put the conduit inside the trench and then cover it up. And you can see the trench heads back toward the workshop. So once I get the conduit straps on this conduit and I've got it securely fastened to the wall, I'll go ahead and cut the metal soffit so I can get both pipes and get the soffit back on there, and that'll wrap the exterior up. And then the next thing I'll have to do is pull the meter and then take this 3/4 inch conduit coming out of the bottom of the meter box, go ahead and take it out, because that's where the double tap is.
It's double tapped into the bottom lugs of the meter, which also feed the house panel, and then this also feeds in that same trench that I dug out and feeds the workshop. So I'll need to get the old service entrance out of the trench and then put the new one in.
All right, so for installing my 1.25" pipe straps, I'm going to use some tap cons since I'm drilling into a block wall. Before I can screw in the tap cons, I need to take my hammer drill here and drill 2 pilot holes to secure the tap cons in. So that's what I'm doing here. I'm just taking the hammer drill, drilling in a couple of pilot screws, and then I'll go back and put the pipe strap on and then screw in a couple of tap cons. As you can see, the conduit just barely misses my dryer vent, but it made it by. And then I put in 3.25" pipe straps all the way up the wall just to securely fasten it. I went ahead and used my 10 snips to just cut 1.25" semicircle. Actually, it was a little bit more than 1.25" in the aluminum soffit. And then I went ahead and put it back in place the way it was.
Okay, so the next thing we're going to do now that the new service entrance is installed to the house. It's still not installed all the way to the workshop, but it is installed in the house up in the attic. So now what I need to do is I need to kill the power to my house, and in order to do that I'm going to pull the main meter. Now this is very dangerous and you should never do this, but I'm going to have to pull the meter. I've got insulated gloves I'm going to use to pull the meter and to remove the double tap at the bottom of the meter, which was my old service entrance into the workshop. And once I get that taken off, then I'll be able to go up in my attic, pull the new service entrance that's up in my attic, pull it down to my panel and install it on a new 100 amp breaker that I'm going to put inside the house panel. Alright, so let's go ahead and do that. Okay, so here you can see this is the double tap here at the bottom of the meter. Now we're hot at the top. The lugs at the top are hot, coming from the Bauer Power Company. The lugs at the bottom are not, but I'm still wearing insulated gloves. So we need to undo these lugs and take out the double tap and totally get rid of it.
I'm going to use a 1/2" socket wrench to loosen the lugs on the hot lines coming in on the 2 bottom lugs. And you can see here I'm removing the first hot wire, which is the black wire, and then I'm going to move over to the white wire. As I had mentioned previously, this was 6'2" in a ground, so basically the white was not neutral, it was an actual hot leg. and then you've got the bare ground that's tied into the neutral leg of the bottom lug coming into the house panel. And you can see I'm being very cautious not to get anywhere close to the lugs on the top side of the meter, because it could arc and hit that socket. Okay, so now that we're getting ready to tighten the lugs back, you always refer to the inside of your panel for your torque specs on torquing down these lugs. The lug torque specification for this particular meter box is 250 inch-pounds. That converts to 20 foot-pounds. So I have a torque wrench, I have it set up for 20 foot-pounds, and that's what I'm going to use to tighten down the lugs. So again, you know, I'm using a 1/2 inch socket. This ratchet is a torque wrench. I think it's one that I think I picked it up at Harbor Freight. It might be an Illinois Tool torque wrench. You know, it wasn't that expensive. And again, you know, I set it up to 20 foot-pounds because the torque specs were 250 inch-pounds. But, you know, I think the torque wrench goes up to 120 something foot-pounds, maybe even more. But again, I'm just being very cautious here to not get anywhere close to the top lugs of the meter, especially with this torque wrench, because it was a big piece of metal to have in your hands, being that close to a live wire. Of course, it'd probably be better to have all insulated tools, but unfortunately I just can't afford that for a one-time small project. So I'm just being overly cautious to make sure that I keep my distance from those top lugs, and go ahead and get the lugs on the bottom half of the meter torqued back in, and then everything is put back exactly as it was before I created the double tap into the meter. So our two hot lines are now torqued back in to specs, 24 foot-pounds. Our neutral is already torqued back, so everything on the lower end of the meter is torqued back to specs. Now I'm going to take the wire nut loose and go ahead and pull the old service entrance out, and then I'll just use a knockout seal to seal up the bottom of this, and the work here will be complete. I'm just going to take a flat blade insulated screwdriver and use that to take off this lock nut that's holding this bushing in place. And once I get that out, then I'll be able to cut the conductors and pull them out of the bottom of the box. Now I'm just going to take my Kleins and one by one, you know, cut the two hot legs and then the ground. And once I get these cut so there's a flush end on the conductors, then it should be fairly easy for me to just reach at the bottom of the box and just pull down the conduit and pull it straight down and out of the box. And then the only thing I'll have left to do is just put I think it was 1.25 inch knockout seal on the bottom of the meter box. Okay, so now we've removed the 1/4 inch, and now I just need to put a 1/4 inch knockout seal on the bottom of this, and then we'll be complete here at the meter. Okay, so I have a 1.5 inch knockout seal, and I'm going to install that on the bottom of the case. And now the bottom is sealed where the original service entrance to the workshop came out. So now we should be good here at the meter. So now the next thing we're going to do is go inside and start running the new service entrance that's up in the attic, fish it down the wall to the electrical panel, and then set it up inside on the house electrical panel. Okay, so the next thing we have to do is we have to get the new service entrance for the workshop into the panel. So what I'm going to have to do is I'm going to have to take one of these knockouts at the top of the panel and take out either 1 inch or 1.25 inch knockout
So let me go ahead and knock that out with a screwdriver.
The knockout at the top of the panel had concentric rings, so the first thing I did was knock out the 3/4 inch knockout, which was fairly easy, came out fairly easy. And then I had to knock out a smaller ring, which was the 1.25 inch ring. That one was a little harder to get out because it's not just a solid piece of metal. It's literally just a ring with a 3/4 inch hole on the inside. But once I did get that out, then I could take and install the plastic bushing where the knockout is.
All right, so now with our bushing installed, and all that is just to keep the edge of the box where I just broke out the knockout, because it's sharp, to keep it from just cutting into the insulation when the supervisor and myself try to pull down the conductors. So that's going to be the next thing. I'm going to go up into the attic. Supervisor's going to stay here with the fish tape. She's going to fish the tape up to me. I'm going to tie them onto the conductors, and then hopefully she'll be able to pull them out. All right, so that's going to be next. Thanks.
My husband is in the attic. He is gonna tie the wire and then I'm gonna pull it. So let's hope that I can pull it easy, fast, and accurately. Otherwise he's gonna be burning.
Wow, a cameo by the supervisor. But one question, why is she whispering? Do you think I'm going to get in trouble for not editing this out? I probably will, but you know, it'll be worth it.
We're gonna get ready to pull it now. So this went easier than I thought. The last time we did something like this, it took a while to get the wire all taped up and everything and pulled back. There's like a beam of wood that goes across here that kind of makes it difficult. But I'm very proud of my husband. He's a good handyman. So I'm just waiting to get the go to pull, slowly of course. And when he tells me to pull, then we pull. Sounds like there's some drilling going on upstairs. That isn't. Pull? Yeah. Okay. We're getting ready to pull the wire now. So slowly, we're holding this. Hold on. Okay. All the way to where you told me. Pull the wire, everything went great. All right. Yes.
Okay, so now that we've got the service entrance into the main house panel, I'm going to take now and wire everything up. We've got our ground, which is going to go to our grounding bar over here, and we've got our white neutral which is going to go to the neutral bus. And then we've got our 2 hot legs that are going to plug into the breaker. And we have a 100 amp breaker here.
So just to note, when you're buying breakers, you have to buy a breaker that's compatible with your panel. This particular panel is a Cutler hammer. So I had to make sure that I bought a 100 amp Cutler hammer breaker. And now I'm just fishing the ground, trying to get it behind most, if not all, the wires, so I could get it to the other side of the panel and then just drop it straight down, and then fasten it to the grounding bar. I think once I got down here, I did have to relocate one of the existing grounds, relocate it up the grounding bar, so I'd have more room at the bottom to fasten this, because like I said, I think this is a number 6 ground. So I didn't have to buy a bigger lug for it. It was the right size that it would fit in the existing ground bar, so I didn't have to buy a larger screw-in lug because of the gauge of the bare copper. I'm not sure if the smaller connections here required a certain torque spec, and even if they did, there's no way that I'd have a tool that I could measure the torque that I was putting on it. So, this was just basically a flat blade screwdriver screwing it down into the grounding bar. So after I completed the installation of the ground, I kind of moved over to the neutral. So the first thing I did, I had a lot of excess, so I went ahead and just trimmed it down to the length that I think I needed, and then basically just dry fit where it's going to go. Now, this is a 4-gauge wire, so you can see that the lug is a lot larger on the neutral bus to allow for the 4-gauge. So I just dry fit it first, make sure it was going to fit, then just took a straight razor and peeled back the insulation. I peeled it back about 1 inch. You don't have to worry about cutting into the conductors here. So I just measure back 1 inch and cut all the way around the insulation, and then score it one time, and then just peel it back. And then once I get all the insulation peeled off, then I'll insert it into the lug and tighten it down. And again, there was really no torque spec here. There might have been in the panel that required a specific torque spec, but like I said, I didn't have a tool to measure that. So again, I'm just using a flat blade screwdriver and tightening it down as tight as I could. But once I did tighten it down, I tried to jiggle it back and forth, because that will loosen it, since this is stranded copper instead of a solid copper wire, and that will allow you to tighten it down a little bit more as you go. So once I got the ground or the neutral installed, I moved over to my breaker, made sure that I had the lugs loosened on the breaker, and then I basically did the same thing with the black hot and the black red. Basically just dry fit them, cut them to length, and then once I cut them to length, I went back and stripped off the insulation just like I did for the neutral, and then I'll take and insert them into the breaker and tighten them down. Now I chose to do this with the breaker out. I just thought it would be easier, and I wanted to make sure that I had good connections, since I am dealing with 4-gauge wire, which is a fairly large wire. If I was wiring just a typical circuit, I would have wired it with the breaker in place on the bar. But because of the size of the wire, I wanted to make sure that the connections were fastened down properly and they weren't going to be too loose. So I chose to do this without the breaker being installed. But once I got them installed in the breaker, then I proceeded to install the breaker into the panel. And like I mentioned previously, this is a Cutler hammer panel. I've got a 200 amp main breaker feeding the panel. And as you can see, this was the last two open slots in this panel. I had mentioned that we had installed another sub-panel breaker that feeds our tiny house. I think it's on a 60 amp breaker, but this happened to be the final breaker for this panel, and this is a 100 amp panel. But our house panel is now full. I really don't have any room to expand. But once I get the breaker in, the work here at this panel should pretty much be done.
Okay, so that completes the installation of the main breaker for the sub panel that goes out to the workshop. It's a 100 amp panel or breaker, and then we've got our 4 gauge wire, which we installed up in the attic and back outside, and then it runs over to the workshop. I've got my neutral tied into my neutral bus, and my ground tied into my ground bus, so we should be good to go. Well, that's going to wrap up this video on upgrading the service entrance to the workshop. As noted previously, this is strictly a video for entertainment purposes only. This is not an instructional video, this is not a how-to video, and this is not an educational video. Do not attempt to do anything that you see in this video, because it will result in your death. I hope this video helps you in your project. I'll leave a link in the description below to all the tools that I used in this project. Let's hope the supervisor isn't watching this one. If not, I'm going to be in the doghouse. If you're new to the channel and you like DIY projects, hit that subscribe button and ring that notification bell. We'd love to have you on board. I'd like to take a moment and thank all the new subscribers to the channel. Your comments and support are greatly appreciated. I'm Rick with the Ingrain Workshop, signing out. We'll see you next week, and thanks for watching.